Look at your arm for a second. Really look at it. You've got skin. Pink, brown, freckled, whatever you've got. And scattered across it, these thin, wispy little hairs that couldn't keep a hamster warm in summer. Now go look at a picture of a chimpanzee. That thing is wearing a winter coat it can never take off. Gorillas, orangutans, monkeys, basically every single one of your close cousins is furry head to toe. You are the naked ape, literally. Out of about 5,000 mammal species on Earth, only a handful decided to just ditch the fur entirely. Elephants, rhinos, naked mole rats, whales, and you. So what happened? Why did humans lose all their body hair? Your first instinct is probably something practical. Less hair means less bugs. Or maybe we just got cold and invented clothes so we didn't need it anymore. Or maybe it was some random accident. The honest answer is weirder. It took way longer, and it almost killed us. And the reason you are sitting here mostly hairless reading this is directly connected to why you can run a marathon, why you have a giant brain, and why you sweat through your shirt in July. Here's the thing. Our ancestors were not born naked. 6 or 7 million years ago, the last common ancestor we shared with chimpanzees was absolutely covered in thick fur. It lived in forests. Fur was great. It kept you warm at night. It protected your skin from the sun, from thorns, from bites. Every primate had it. It was the default setting. Then the world changed. Starting about 3 million years ago, East Africa started drying out. The dense forests shrank back, and in their place came open grassland. Hot, sunny, windy savanna with almost no shade. And some of our ancestors walked out into it, standing up. That standing up part matters a lot. It's called bipedalism, which is just a fancy way of saying walking on 2 legs. When you stand upright in the African midday sun, you expose a lot less of your body to direct sunlight. A chimp on all fours is basically a horizontal solar panel. A human standing up is a vertical stick. Less sun hits you. That helped, but it wasn't enough, because the savannah is brutally hot, and if you're out there in the middle of the day trying to find food, you will overheat fast. And overheating kills you way faster than being cold does. This is where the story changes, because most mammals cool down by panting. Dogs pant, cats pant, chimps pant. You can only pant so hard, and you can't pant while you're running full speed. Try it. Humans invented something completely different. Sweat. Not just a little sweat, an insane amount of sweat. You have between 2 and 4 million eccrine sweat glands spread across almost your entire body. That is basically your body's built-in sprinkler system. Eccrine glands just mean the sweat glands that dump watery sweat directly onto your skin to cool you off through evaporation. Chimpanzees have them too, but only a fraction as many. You have about 10 times more than they do. Now here's the problem. Sweat only works if it can evaporate. If you're covered in thick fur, sweat just gets trapped in the hair. It drips off uselessly. It can't pull heat off your skin. On bare skin, evaporation is 2 to 3 times more efficient. So suddenly, fur went from being life-saving insulation to being a deadly winter coat in the desert. If you were a hairy hominin trying to chase food across the savannah at noon, you overheated and you died. If you happened to be born with slightly thinner, shorter body hair, you could dump heat faster, run longer, and live. That is natural selection doing its slow, brutal job. Over hundreds of thousands of years. The anthropologist Nina Jablonski at Penn State has spent most of her career studying exactly this. She calls skin the original human interface, and her work is the backbone of what we now call the body cooling hypothesis, also known as the savannah hypothesis. It is still the most widely accepted explanation for why we lost our fur, and the timeline fits. The first member of our genus Homo to go basically hairless was probably Homo erectus, about 1.6 to 1.7 million years ago. Homo erectus was tall, long-legged, fully bipedal, and living right out on that hot, open savanna. Genetic evidence suggests that's roughly when we became furless, but losing your fur in equatorial Africa creates a brand new, very serious problem. Sunburn, skin cancer. Your skin is suddenly naked under a UV blast furnace with no protection at all, so evolution had to fix that immediately. And it did, with melanin. Melanin is basically your body's built-in sunscreen. It's the pigment that makes skin dark. Early humans, before they lost their hair, almost certainly had light skin under their fur, just like chimps do. Once the fur went away, dark, high melanin skin evolved fast, because anyone with pale, naked skin got fried. You can actually date this. There's a gene called MC1R that controls melanin production. A key variant that gives you melanin-rich, dark skin showed up around 1.2 million years ago. That tells us that, by that point, we were already mostly hairless. You don't need sunscreen skin unless you've already lost the fur coat, so the hair loss happened first, then the dark skin followed as armor. Think about that for a second. Humans lost their body hair so long ago that our skin literally changed color to compensate. And losing fur didn't just let us run around in the heat. Nina Jablonski argues it helped make possible something even bigger, our enormous brain. Your brain is the most temperature-sensitive organ in your body. Cook it by even a few degrees and you're in real trouble. Being able to dump excess body heat through naked, sweating skin let Homo erectus keep a big, hot, hungry brain cool while it was active during the day. No fur, better cooling, bigger brain. That is not nothing. Now here's where it gets interesting. Because if heat was the only story, we should be completely hairless, like a dolphin. We are not. Look at your head. You still have a thick mop up there. Why? Because your brain still needs a sun hat. Scalp hair protects your head from direct solar radiation and reduces water loss from the top of your skull. Jablonski's lab actually tested this recently. They found that tightly curled hair is the best of all for this job. It lets air circulate while blocking the sun. That is exactly the hair texture that first evolved in humans living under the equatorial sun. Softer, straighter, flowing hair only showed up much later, after humans spread out of Africa into cooler climates. So head hair stayed. What about the other patches? Armpits, pubic hair, eyebrows, eyelashes, face hair if you're male. None of that is an accident either. Eyebrows and eyelashes are easy. They keep sweat and dirt and rain out of your eyes. Eyebrows are also incredibly important for human communication. Try making a facial expression without moving your eyebrows. You look like a robot. The armpit and pubic hair is weirder. Most primates actually have finer hair around their genitals than on the rest of their body. Humans are the exact opposite. We kept thick hair there on purpose. The leading idea is pheromones, or at least scent. Those regions are packed with a different kind of sweat gland called apocrine glands. Apocrine sweat isn't watery. It's oily and full of chemicals that bacteria break down into body odor. Hair in those spots traps that scent and spreads it. Our primate ancestors definitely used pheromones to communicate. Whether modern humans still do is, honestly, debatable. There is no good evidence we do. Biologist Tina Lice at the University of Southern California thinks that armpit and pubic hair might just be what scientists call a spandrel. That is a fancy word for a leftover. Basically, architectural leftovers from an old system we don't really use anymore. Like a weird little alcove in an apartment that used to be something. It could be that, or it could still be doing something subtle we haven't figured out. Reducing friction and chafing during walking and running is another solid guess. Your thighs rub together a lot when you walk 20 kilometers a day, so the body cooling story is strong. It has the most evidence. But it is not the only theory, and the honest answer is it was probably several things at once. One of the coolest competing ideas is the ectoparasite hypothesis. That is a very sciencey way of saying lice, fleas, and ticks. In 2003, evolutionary biologists Mark Pagel and Walter Bodmer published a paper in the Proceedings of the Royal Society B arguing that humans went hairless because naked bodies have fewer hiding places for parasites. Less fur means fewer ticks, fewer lice, fewer nasty biting things, giving you diseases. And a hairless mate was basically advertising, hey look, no bugs on me, I am healthy. Sexual selection would then accelerate the whole thing. Humans started preferring less hairy partners, and over generations that preference made everyone even more hairless. That sounds ridiculous. It isn't. We know body lice evolved specifically to live in clothing, which means we were already mostly naked before we invented clothes. Melissa Toops and David Reed dated that split between head lice and clothing body lice to somewhere between 70,000 and 170,000 years ago. Meaning humans were running around hairless in Africa for over 1 million years before anyone put on a shirt. So no, we did not lose our hair because we invented clothes. We invented clothes because we had already lost our hair and then wandered out of Africa into cold places and needed help, not freezing to death. There is also the plain old sexual selection theory by itself. Maybe less hair just looked good. Maybe it signaled youth, health, fertility. Darwin himself liked this idea. It is hard to prove, but it almost certainly played a role in finishing the job once natural selection started it. You will sometimes hear the aquatic ape hypothesis that humans lost their hair because we spent a phase living in water, like whales or hippos. It is a fun story. There is basically zero fossil or genetic evidence for it. Don't worry about that one. So which one is true? Probably all of the main ones, layered together. Heat was the big engine. Parasites and sexual preference were the accelerators. Big brains were the bonus prize. And here is the wildest part. We never actually lost the ability to grow fur. Your body still knows how. In early 2023, a team led by geneticist Nathan Clark at the University of Utah, working with Amanda Kowalczyk and Maria Cecchina at the University of Pittsburgh, published a study in the journal eLife where they compared the genomes of 62 mammals, hairy ones and hairless ones. What they found was crazy. Humans appear to still have all the genes for a full coat of body hair. Evolution didn't delete them. It just switched them off, like putting tape over a light switch. They found the same pattern in at least 9 different hairless mammal lineages: elephants, rhinos, naked mole rats, dolphins, pigs, all of them. Nature keeps arriving at the same solution independently by deactivating a common set of genes and regulatory regions that build hair shafts and control hair growth. That means your genome is sitting there with a full fur coat locked inside it. Sometimes that switch flickers back on by accident. That is why conditions like hypertrichosis exist, where people grow thick hair over their entire bodies. It is rare, but it proves the blueprint is still in there. We are not the naked ape because we lost the instructions. We are the naked ape because we turned them off on purpose. There is even a broken pseudogene called KRT41P in the human lineage, which helps produce keratin, the protein hair is made of. It stopped working about 240,000 years ago. That is one of the tiny molecular scars left behind from when we walked away from fur for good. Think about the trade-off we made. We gave up a built-in coat that protected us from sun, cold, thorns, bites, rain. In exchange, we got a body that can dump heat like a radiator, run for hours in the midday sun, grow a massive, energy-hungry brain, and survive persistence hunting on the savannah. Persistence hunting was Homo erectus' secret weapon. You don't need spears or bows if you can just jog after an antelope for 5 hours in 40-degree heat until it collapses from heat stroke. You can't do that in a fur coat. No other predator on the savannah could do that. Humans could, because we were sweaty and naked. That one weird physiological trick basically changed everything about what it means to be human. And it came with costs. We became incredibly vulnerable. A naked, sweaty ape without claws or fangs is not very impressive in a world full of lions and hyenas. We had to get smart fast. We had to cooperate. We had to make fire, build shelters, make clothes from other animals' fur because we threw away our own. Nakedness forced us to become social in a way no other primate ever had to. You cannot survive a cold night on the savannah alone with no fur. You need a fire. You need other bodies close to you. You need someone watching while you sleep. Our hairlessness made us dependent on each other. It made us build culture. Clothes, shelter, jewelry, tattoos, all of that starts as a replacement for the fur we lost. Eventually, it became art, identity, shame, fashion, everything. We took a biological vulnerability and turned it into the entire human world. So why did humans lose all their body hair? Because about 2 million years ago, in the heat of East Africa, being furry would kill you faster than being naked. Sweat on bare skin let us run, hunt, think, and cool a giant brain. Parasites and mate choice probably helped push it along. Dark skin evolved to protect the skin we exposed. And once the switch was flipped, we never flipped it back. We traded a coat for endurance. We traded insulation for a brain. We traded independence for each other. And now, here you are, 2 million years later, looking at your nearly hairless arm, probably in an air-conditioned room, wearing clothes made in another country, wondering why you have to shave. You are looking at the oldest piece of human technology there is. Not fire, not tools, just naked skin. It was the first thing that made us human, and you are still wearing it.